We are really happy to be talking about one of the biggest challenges that we face, which is effectively migrating your Microsoft workloads to AWS, especially for some of those end-of-life workloads. Thank you everybody for attending. A couple of ground rules for GoToWebinar. If you have a question, please type it up in the box, the chat box. Click the raise your hand button. Let us know, and we will get to the questions as soon as we can. This is meant to be, this is for you, so please, if there's something on your mind, let us know. I'd like to introduce from AWS, my co-presenter, Mayur. Mayur, thanks for being with us today, and I understand that you have some material that you'd like to go over regarding migrating to AWS.
Yes, thanks, Eric. Thanks for having me. So hi, everyone. My name is Mayur Dewaikar. I'm part of the EC2 product management team at AWS, and my focus at AWS is Microsoft Workloads. So what I'm going to be talking about today is a program we have to help customers migrate their end of support workloads over to AWS without requiring any kind of recoding or refactoring of the applications. So Eric, if you could make me the presenter.
Yes, I can. One moment.
Excellent. Okay. Let me just pull up my slides. Okay. Okay. Do you see my slides, Eric? Just to confirm.
Yes, I see them.
Excellent. Okay, so let's dive into the content. So Microsoft end of support deadlines, we've had one very recently with the end of support of 2008 and 2008 R2. So that happened in January 2020. We have another one that is right around the corner for 2012 and 2012 R2. And I say right around the corner mostly because most customers that want to take action on end of support workloads are doing so about 18 to 24 months ahead of time. So if you have existing 2008 workloads, we already have a program for you, and we'll talk about that in these slides. But if you're starting to think about what you will do about 2012, this information is also going to be relevant for that planning process. So end of support has a lot of different implications on enterprise customers. The first one is around security. So when Microsoft announces end of support for a certain operating system, they essentially stop supplying security updates on that particular operating system. So that essentially just increases your exposure to security risks. So that's a major problem in enterprise setups. The second problem that enterprise customers run into is around compliance. So if you're running an end of support operating system, chances are that you are not in compliance with the regulations that have been set by your organization. So compliance becomes an issue. In most cases, when you have an end of support operating system, you have to run that operating system in isolation, mainly because you don't have access to security patches, and you want to make sure that that application is not able to get in touch with the other applications and vice versa in your setup. If you want to keep continuing to keep that operating system around, Microsoft does offer an extended support option, which is very expensive, almost prohibitively expensive. And then finally, if your plan is to take these applications over to the cloud, most of the cloud providers actually do not have the ability to distribute the armies or instances for those 2008 or earlier workloads, right? So if you want to take those workloads as is, then that becomes a problem because you're not going to find a version of that operating system running in the cloud because the cloud vendors cannot distribute that. So when you migrate to a new version of the operating system, most of these problems go away. You are usually in compliance with your security posture, and you're able to also move to the cloud. So that's basically what we're going to talk about. So the question that comes up often is, so what are some of the challenges customers are running as it relates to end of support workloads. So the first one is around just loss of expertise and loss of installation media. Most of these applications have been built several years ago. In the case of 2008, 12 plus years ago, right? So when we talk to customers, we often find that the people that had built these applications are no longer with the company, and so they don't have the option of recoding these applications without a lot of effort, right? So we've got that problem, which is the biggest problem we run into. The second problem is that when you have to refactor or recode a legacy application, you have to invest a significant amount of time and money to go through that effort. The third thing is the risk of failure. So if you try to do an in-place upgrade of the application, many of the times the new operating systems will not have the runtimes that the application needs, and so that application is likely to fail when you go through that upgrade process. We also often find that customers have highly customized commercial off-the-shelf applications, which are just not compatible with the new version of Windows. And then finally, the dependencies we have on the older runtimes, it could be Java related or it could be .NET related, that also prevents customers from upgrading the applications to a new version of Windows. So keeping all these problems in mind, we launched the end of support migration program for Windows Server last year at our reInvent conference. And we were basically trying to solve these problems for customers. And that's basically what this program does. So it basically allows customers to package legacy applications without doing any kind of code changes. So I'll go through the exact process for how EMP actually works. And I also have a demo where I will talk to you about how the EMP packaging actually works in practice. So the EMP program consists of our tooling, which is what we use to do the packaging of the application. And then if you need access to experts, then we have our partners such as Mission Cloud, or we also have our own professional services team called ProServe that can help you with any technical help that you might need on the packaging of these applications. So EMP allows you to basically future-proof your applications. So as part of the EMP packaging process, we are decoupling the underlying operating system dependencies that the app has, and we're basically packaging that in a self-contained package, which allows the app to run forever within that package on a new version of the operating system. So because we are able to package the application, move it to a new version of Windows, we are eliminating the risk of any security exposure, mainly because when your app is moved to a new version of Windows, you are getting the new security updates and patches that Microsoft puts out. So that eliminates your security risk. It also brings you in compliance with industry regulations and any other IT regulations that your company might have already put in place for these applications. So it brings you in compliance. And then finally, because we are taking an approach where we don't require any kind of refactoring or recoding of the application, and the fact that we are now bringing you current with the latest version of Windows also means that you don't have to pay expensive support costs. So we bring the cost down pretty dramatically of running these applications on the new version of Windows. So then the question comes up about where should we use EMP? So it's typically the 80-20 rule. What we find in a typical customer deployment is that when we are talking about end of support workloads and we look at a sample of what the customer has, 80% of the workloads can be addressed by doing an in-place upgrade of the underlying operating system. So if you have the application, if it's compatible with the new version of Windows, you can just do an upgrade of the operating system, and that takes care of the end of support problem for you. But then there are the 20% workloads, which is where you have the issue of the application not being compatible with the new version of Windows, and that's where the EMP packaging really helps out. So we'll talk about that a little bit more on how we help out with that particular kind of use case. So our EMP process, typical engagement, has 4 steps. So in the first step, which we call discovery, we will sit down with you. We will take a look at the applications that need to be packaged. We will look at whether that application can be upgraded in place by taking care of the operating system. So the in-place upgrade that I was talking about. If we cannot do that, then we will look at the application. We look at what are the different dependencies the application has within the setup. So that's the process we call discovery. We look at what are the different user accounts we might need to access different services. And we will look at, if we need access to Active Directory or any other services, right? So that's called a discovery process to understand how the application works and how it works with the other services in the environment. Sometimes it's a straightforward single tier application, so that's fairly straightforward, but sometimes we also deal with very complicated multi-tier applications which have dependencies with multiple different services in the organization. So we've got that discovery process, which is step 1. Step 2 is the actual packaging of the application. So in the packaging process, we have our the tooling, which I'll show you in the demo. So we install the tool, and then the tool basically does a snapshot of the setup before. And then when we do the capture of the way the application runs, if we have an installation media and we are doing the install of the application, we capture all the dependencies the application has, and then we do a post snapshot. So we do a pre-snapshot and a post-snapshot, and then we're basically just doing a diff against those 2 snapshots to understand what are the different dependencies the application has. And then in the package, what we essentially do is we take all of those dependencies that the application is calling upon. That might be specific to an older version of Windows. So let's say in this case, it's 2008. We'll take all of those 2008 dependencies, any of the runtimes, and we will just put that in one package. That package can then be taken into a production setup. So let's say we package the application on a 2008 server, and your intent is to run that application on a 2016 or 2019 version of Windows. We will take the application, we'll take that package, we will move it over to that new version of Windows, and then we go through a testing process where we will make sure that everything we have packaged is working correctly, and then we move the application into production. So it's basically a fairly straightforward 4-step process. I'll show you how that works in the demo that's coming up. So what we are doing in a nutshell is we are intercepting any Windows API calls that are happening in the setup, right? So any calls that are going to the legacy version of Windows, we are intercepting those calls, and we are offering those resources to the application from within the package itself. So the application thinks in reality that it's actually working on an older version of the Windows operating system, because it's still getting access to those runtimes, it's getting access to all those dependencies that it might have. But in reality, what we have done is we have actually put that application in a package, and we have taken that package and moved it over to a new version of Windows. So the really nice thing about the package is that it's a completely self-contained environment. So we're running it in isolation, and that eliminates the risk of having any other applications access to that packaged application, right? So we eliminate the need of, we eliminate the security exposure that might be happening by completely isolating this application in the environment. So you've got the base operating system, which will be the one that the customer is running. So 2012, 2016, 2019, which are the ones that are supported by Microsoft today. And then you've got the EMP compatibility package sitting on that operating system with the application running within it. So we are resolving any OS incompatibilities as part of this process while maintaining integration with other applications and other services in the setup. So the question that often comes up is, what is the overhead of running the application in this kind of a package? So the overhead is very, very minimal. So the CPU hit is less than 1%. We only need, give or take, about 10 megs of disk space, and the memory utilization also remains very low. We're not installing any agents or clients for this application, and then there is no additional infrastructure needed to run this application either. So it's a very, very lightweight packaging. Most cases, the customers don't even realize that the application is running on their ARMY or the Amazon ARMY. So it's a very low impact packaging process. So we've had customers deploy the EMP solution quite a bit. We have these 3 customers that were a couple of the early adopters that we had in our program, and they've seen great success just bringing their end of support workloads from on-prem over to AWS, and really kind of eliminating the need for any kind of refactoring or recoding of their legacy applications.
Mayur,
so yeah,
I just want to ask a question real quick. Does the EMP package itself cause any issues with anything customers might be currently running, such as antivirus or any of those monitoring type systems?
No, so the application is running in a completely self-contained setup, and we have not had any issues with any other third-party applications that might be running. So there seems to be absolutely no impact on the application from the other applications that might be running on the customer setup. So no impact at all.
I didn't think there would be, but that's usually one of the things that comes first to mind when customers start looking at something like this. Thank you very much.
Yeah, no problem. So just a quick word on how licensing works on AWS related to Windows workloads. So we have 2 ways in which we can essentially license the Windows workloads. So the first one is what we call license included. So this is your flexible pay-as-you-go model, where we are reducing your enterprise agreements or SCEs that you might have with Microsoft. So this is a license and an instance of Windows that is offered to you by Amazon. So you buy from us, we will give you the instance with the license included, whether it's a Windows license or a SQL license. We just take care of that for you. There are no client access licenses required for that, and there are no software upgrade fees either. So we manage the ARMYs for you. We also manage licensing compliance. And this kind of a model is also compatible with the Amazon managed services. So this is the most popular option that we have today, which is license included, right? So you basically buy the service, you buy the license for the Windows components directly from Amazon, and we take care of all the upgrades, the patching, all of that. We take care of that for you. So this is the most popular license included option. We also have a second option, which is called bring your own license. So we have a lot of customers who have existing licenses with Microsoft through their EAs, and they simply just want to bring those licenses over to AWS to be used on the AWS platform. So we have the option of managing these licenses that you bring to AWS through a service we have called AWS License Manager. So AWS License Manager is a really cool service. It actually allows you to manage licenses on AWS also manages on licenses on-prem. So if you have any licenses that you are managing on-prem for existing Windows instances, we can manage those directly from within the license manager tool that we have. So it's a really good license management utility that we offer basically at no additional cost to customers. And then the patching of these solutions or these instances that you bring over will also be managed with a tool called AWS Systems Manager. So the AWS Systems Manager, again, manages all the life cycle of the AMI, the patching, all of that. We will take care of that using that tool. So within Bring Your Own Licenses, there are two options. So for customers who want to bring over licenses without paying Microsoft software assurance, we have an option called dedicated hosts. So the benefit of dedicated hosts is that it allows you to benefit from the efficiencies of the cloud while utilizing your perpetual licenses. It also allows you to license SQL using physical cores, which is a huge advantage if that's the your preferred route versus trying to license SQL using virtual licenses. And then finally, it allows you to really maximize the virtualization benefits of the Windows Data Center Edition and SQL Enterprise Edition, right? So depending on the licensing that you have with Microsoft, you can really use this in a very flexible way to get a very similar experience on AWS. We also have something called a shared or dedicated instance. So if you are paying for license mobility to Microsoft, then you can bring your license mobility benefits directly over to AWS. And it allows you to run your test dev workloads with MSDN subscription on dedicated instances. It allows you to run workloads like SharePoint, Exchange, and remote desktop service, etc. Right? So all of these things that require license mobility, that they can be used on a shared or dedicated instance with the license mobility option. So we have a lot of flexibility. We also have some really cool features on our roadmap. So one of the options that we are working on right now, for example, is called license conversion. So if you have the need to convert between your license included and BYOL or go from BYOL to LI, we are going to very imminently provide an option that will allow you to do that. So there's a lot of flexibility in terms of how you can license your Microsoft workloads on AWS. If you have existing licenses, we want you to bring those over by all means. We don't want you to repurchase those licenses again from us. That would just be unfair. So we give you a lot of options when it comes to licensing on AWS. So with that, I'm going to actually show you a quick demo of our EMP technology. So Eric, can you see my screen with the demo?
Yes, I can.
Excellent. So I have here a Windows 2000 SQL Windows, sorry, it's a SQL 2000 that I'm trying to run on a Windows 2019 instance. Now, SQL 2000 doesn't work on Windows 2019. So if I try to run it, it's going to fail. I can do some basic compatibility fixing to see if it'll work. So I'll try to run this in compatibility mode and see if that will take care of it. And chances are that that's not going to work either, right? So you'll see that it fails. So basically, to solve this problem, what we are going to do is we're going to take this SQL 2000, we're going to take it to a version where we know it works. So this is a Windows 2003 instance where we know this SQL instance is going to run. We are going to install the compatibility package builder, which is the EMP package, the tooling that I was talking about. So this is what we're doing here. So we're installing the EMP tooling. So when we launch it, this is what it looks like. What we're doing now is we are creating a folder where we are going to put the package. And what we're doing now is we're starting a capture of the setup, right? So we're doing a snapshot before the application is installed. So this is the pre-snapshot that I was talking about when we were going through the presentation. So that's what the tool is doing right now. It's just doing a snapshot of the setup before the application is installed. So that snapshot or pre-installed snapshot is completed. Now we're going to install the application. So in this case, it's SQL 2000. So we are installing SQL 2000 just as we would, and what the application is doing is it's basically observing what is happening in the setup, right? So it's looking at what are the different reg keys, what are the different files that the application is creating as part of the installation process, and it's just basically keeping track of all of that. So that tool is doing that. So we'll let this finish, okay? And then once the application is installed, we have to go in and actually run the application to see what are the things that the application is going to call upon. So these are all the shortcuts that the installer created. And we're going to go in and launch the service manager for SQL. And what that allows us to do is basically look at what is the SQL Service Manager calling upon, right? So what kind of reg keys is it creating? Are there any other files that it's creating, any other services that it needs to capture? And then when we hit next, we are going to complete the capture, which basically just means that we are going to end the packaging process here, right? So we did the install of the application, we launched the application to see what it was calling upon in terms of reg keys, in terms of files, any other services, and then we're just going to complete the capture at this point. So once the capture is complete, we will go in and look at what we've got as the package. So on the left-hand side, you see the files that we got in the package. So these are all the files that were created by the application. And this is what was in the package during install. What you see on the right-hand side is what was requested, the files that were requested at runtime, right, by the application. So we've got a list of all of this. If there's anything that we need to remove from the setup, we can do that. So this is just allowing us to edit the package that we are creating. Here we are capturing reg keys, so any reg keys that were in the package during install, and then reg keys that were requested by the package during runtime, right? So we've got those two similar to the files that we captured, and then we can determine if there are any reg keys that we need to exclude and just finalize the package, right? So once we have looked through everything, we can just go in, we can give the package a name, and then we just say a package application. And what that does essentially is it just dumps everything in a folder on the machine, in that folder that we had originally created, right? So when we click on open package, this is the package that was created by the tool. We're gonna zip this up now, because what we need to do is we need to take this package from this 2003 version of Windows, and we're gonna move this over into a 2019 version of Windows to run it in that package. So now what we're doing here is we're basically uploading this package from the machine here into an S3 bucket. And in the S3 bucket, we are just dropping the package so that we can download the package from our 2019 server that's running on AWS. So the copy is complete. We are now on a 2019 version of Windows that's running on AWS. What we're going to do is we're going to run a PowerShell command to basically copy down the package that was copied into the S3 bucket so that we can bring that down here on this 2019 server. So we are then going to go into the command prompt. We are going to make some basic checks to make sure the application is ready to be installed. And then what we will do as part of the installation process, which you'll see a command line driven process, we will essentially just run some prescripts and to make sure that the application is installed. So right now we are copying the files over to that folder, and then we are getting ready to deploy the machine, right? So we did that over here. We run some pre-scripts, some post-scripts to deploy the application. So once this is done, we're going to go in and we are going to launch the application. So we launch the service manager to check to make sure that it's set up correctly. So this is done. And then what we are also going to do is we are going to then go into the Enterprise Manager, SQL Enterprise Manager, to establish a connection with a database on the back end. So we're going to start the service and then go in and establish a connection with the database. Okay, so that service has started here. Go into Enterprise Manager, connect with the database, and then we will also, as part of this, just do a quick connection test to make sure that everything is set up correctly. So this is our typical UAT process you'll see when we package the application to make sure that everything is working correctly. So we're just going to do a test here, connection test here. And that is it. So the application was moved over from 2003 to 2019. This is a SQL 2000 version, which is not compatible natively with 2019. But what we have shown you here is that we packaged that application up in a EMP package container, and we moved that over to a 2019 version of Windows. So without requiring any kind of recoding or refactoring of the application. So with that, I'm going to hand it over to Eric, who's going to take us through the rest of the presentation. So Eric, over to you.
Thank you so much. That is awesome, by the way. The EMP is completely, if it would have existed some years ago, it would have been, if you could only go back and do it again. No, I really love that. It takes so much of the complexity out. So thank you so much for demoing that for us, Mayur, and providing us some of that insight into the program itself with AWS and how you can help and some of the challenges folks might face. Again, my name's Eric Ethridge. I am a solutions architect here at Mission. I'd like to talk to you, everyone, today about it's called a case study. I don't like that term, but we'll use it. The Boston Celtics Windows migration to AWS. I'd like to go over that today at a really high level, just give you an idea of some of the things that we do here at Mission and how those can help organizations at any scale be successful. So this is phase one, and I'm going to talk through it, but I want you to know that there was a phase 0, and I'll get to that in a moment. But so the Celtics came to us and wanted us to consult with them. We've had a long relationship with the Celtics before we were even Mission. And they came to us and asked us to consult with them for 3 major aspects of their current IT performance or their current infrastructure performance. They needed some improved performance. They needed reduced costs. Like everybody wants reduced costs, we know that. And they wanted operational efficiency, which actually leads to reduced costs and improved performance. As you can see, it's kind of a trifecta. So we spoke to them about ways that we could help and how AWS could be the major force for all of this. The on-demand compute model for AWS it gives you the flexibility to in capacity and to pay for that capacity that you don't have in an on-premise or a hybrid model. In addition to that, once you start bringing workloads to AWS, the previous bandwidth constraints you saw, both in between machines themselves and interior or internal networks to external networks, start to disappear because of AWS's global backbone. Additionally, you start looking at managed services. I know it says MS SQL here, but any of the managed services at AWS start reducing your operational overhead so your developers can concentrate on developing, your application folks can start concentrating on what they're supposed to do instead of some of that maintenance and management burden that goes with having your traditional model of infrastructure. So the first phase of any of this will be a lift and shift migration, but before this, if you we don't just run in and say, all right, let's lift and shift this because it's a good idea. Before this, there was a phase 0 where the Boston Celtics moved some of their excuse me, where the Boston Celtics moved some of their aspects, such as they moved some of their machines up to AWS to kind of get a feel for it, including linking together their DR site, which was at an alternate play location, as well as their main data center, which was at which was hosted with the rest of their enterprise. And they used AWS to link some of these things together and get a feel for how it could help them. And based on that small toe in the water kind of that small toe in the water approach, they saw the power that it could bring to their enterprise overall. Excuse me. Now, the results of this, it was a runaway success. We actually migrated, we focused on a specific part of this. If you ever get a chance to go to see the Boston Celtics, what's called their war room or their basketball room, they have this panel on the door that says "In Red We Trust," and it's for their intelligence agency. As a former intelligence analyst for the military, I was super excited about this. I thought maybe I missed my calling. I should be a basketball intelligence agent, not a cloud architect, but that's another story. And they have years of data, and I mean just tons of data sitting around. If you think about it, they are making multi-million-dollar decisions about this data. They are determining how their game strategies, marketing strategies, player development, all off of basing all of it off analytics. So one of the things that they want to do is increase their analytics performance. And once we had about 99% of it, after phase 1, we had about 99% of it, the Basketball Intelligence Agency, or BIA, platform for the Celtics running on AWS. That was huge for them because they saw a 75% decrease in data processing time. What was taking overnight for them, which they had kind of like you used to start, it started before they went to bed, and like you'd start the tape backups and then everybody would wake up in the morning and it might be there, now took 4 hours. So they were able to get, they were able to move even closer to game time. They were able to move everything even closer to when the event actually happened, which was huge for them. Happier coach, happier analysts. They were able to, instead of 24 hours later when the game might be a little bit out of the player's mind or the coaches were a little unsure, but they saw they were able to bring that information closer to the actual event, letting them make better judgment calls based on that analysis and what had just occurred. On top of that, if you're not running a server for 24 hours or 14 hours to get this data to go through, you're paying a lot less because of AWS's on-demand model. So you spin up instances when you need them, you spin them down when you don't. There's no server farm just sitting there idle costing you money. When it's not running, it's not costing you money. Excuse me. So all of those things together are force multipliers for helping the Celtics achieve their goals using analytics, AWS, and all that compute power available to them. Excuse me. Now you're thinking, so you move their stuff up to AWS, that's great. Now what do you do? We took a multi-phased approach to this. Phase 1, we got it up there and gave them a proof of concept that this could actually work in the cloud. Then we started optimizing. And the optimization path is a little bit different than what you might think. We actually moved them off of Windows. Now, hold on, this is not a bad thing, because without the flexibility and the inherent and the capabilities of AWS, we couldn't have done this. They were looking for a way to become more efficient, reduce licensing costs, reduce the operational overhead with managing those licensing costs, and assorted myriad other things that I'm sure that folks who have dealt with licensing and all of the overhead that goes with that have experienced. Microsoft allows you to run SQL Server on Linux, so we consulted with them and helped them migrate all of their Windows servers to Linux, including MS SQL. We adopted some more native services. AWS has almost 200. I'm thinking it might be over 200 at this point. Mayur can keep me honest on this, but roughly 200 services. Many of them are able to take the place of what is currently being used, such as if you are running if you're running something like a Rabbit message queue, you can move it to SQS SNS. They adopted Elasticache to improve their performance, having an in-memory cache. They moved their all that historical data, they made it highly performant by moving it to Redshift and then using AWS Glue, which is a managed extract, transform, and load service for data, cleaning that data up, getting it to the format that you need it to. All of this became part of their regular pipeline, running automatically, only costing when it was being run. And moving off of MongoDB as a MongoDB on EC2 or on an instance to a managed service such as DocumentDB, which is a managed version of MongoDB, was absolutely critical for them. Again, a document database is a large amount of overhead. Removing that, taking care of the updates and the patching. Again, this is the buy versus build mentality, and it helped out immensely at letting them streamline their performance. The other big part of moving to the cloud is getting to the idea of infrastructure as code, not treating your infrastructure becomes just that, code. It's you no longer is it infrastructure as cattle or herding cats or anything else. It's just code, lines of code that can be adjusted, spun up and spun down when you need to. So we got them to the point where they could tear up and tear down their whole analytical environment on demand. So if they had to make a change, so to prevent drift, your environment might be immutable. They can tear it all down, make that change, and spin it right back up again. And the horizontal scaling part, where you have those on-demand servers, helps increase resiliency. Instead of increasing size and having to wait for that to come back up or get more cores or take advantage of increased disk space, we scaled horizontally, spreading the workload out among many small machines. And that eliminating some of those legacy inertia points through modernization was really the goal that the Celtics had as we continued to work with them. And the results, if you could spend a quarter less for increased performance by removing your licensing costs, those costs can go back into improving your architecture, hiring the folks that you need, increasing your performance. Doing some of the things that need to be done. Reducing your data processing time, also critical, because it's less time wasted in waiting. And then part of that tear up and tear down with using Terraform, CloudFormation, any infrastructure as code is the disaster recovery aspect of it. The ability to move your entire environment as code with a few tweaks is a far cry from 10 to 15 years ago when you had to drive your tape backups down the coast to the data center that was 100 miles away so that you could bring your environment back up again. And if you think I'm definitely not stretching the truth, because I have talked to a customer in the past year that was their DR strategy, was to drive backups to another data center, not needed anymore. And in the end result overall with the Celtics, mission, we've partnered with them. We're their provider of choice. We move with them as they continue to develop and grow on AWS. We're right there with them, helping them drive those improvements. So that is the end of my kind of talk through of the Boston Celtics case study. Just a really high overhead view of how we help them. Again, phased approach. Really not putting everything out there at once. It is okay to just dip your toe in the water and move forward from there. There's a large amount of comfort that needs to be accepted and inertia overcome as you move to the cloud. I'd like to move us into the Q&A portion now. So Melissa, thank you for putting that in chat. So Mayur, what applications from your experience are best suited for the EMP?
Yeah, so that's a good question. I think most of the applications that we typically see running on Windows are going to be good candidates. The ones that actually do not work well are 16-bit applications. We don't package drivers. We don't package a couple of the other low-lying kernel level modules. But other than that, everything else is basically fair game for EMP. And what we find also is that, as I was mentioning in the presentation, that some of the applications just can be dealt with by upgrading the underlying operating system, right? So that should be really kind of your first step in figuring out whether to use EMP or not. And if the application just cannot be upgraded in place, then EMP certainly makes sense. So that's kind of the route we typically go when we talk to customers.
Excellent, awesome, thank you very much. So should kind of going with this, is there should all legacy applications use EMP?
Yeah, so I think there is a business answer for it, and there is also a technical answer for it, right? So I think whenever we talk to customers, the first thing we ask them to do is take a look at the application and review how critical is it for your business. If the application is not important,
Mhm.
then you should consider either retiring it or just letting it run as is, right? It's not
Mhm.
if it's not something that impacts your business, right? So that's a business decision. And then there is the technical aspect of it, which I think we talked about a little bit in the earlier question, which is if you have a legacy application that can be upgraded in place, great, do
Mhm.
it. That's the path of least resistance. But if you have an app that's not compatible with the new version of Windows, then that's where you use EMP.
Okay, that makes total sense. Thank you. Another question is, so AWS offers a wide variety of instance types when it comes to EC2, including some of these new AMD processors. Is there any processors or instance types that should be shied away from when looking at EMP that aren't suited for it, even though they might be suited for a Windows workload?
Yeah, so because of the really low overhead of EMP on the instance itself, it really
Hmm.
doesn't matter what kind of instance you use, right? So I think the real key on when it comes to picking the instance is that the instance is right sized for the app that you're
Hmm.
running it for, right?
Right.
It doesn't, the EMP package is so lightweight that it really doesn't matter. So you
Hmm.
just have to make sure that the app is sufficiently supported by the instance in terms of CPU, in terms of memory.
Hmm.
So it's an app level decision. It's not really an EMP decision. The EMP overhead is very, very, very minimal.
That's what I figured. I just wanted to ask because sometimes there are some quirks like that. But thank you very much. Um, I don't see any more questions in chat, so I'd like to wrap it up right now and provide our special offer here at Mission. Before I do that, though, I'd like to thank Mayur so much and for participating with us today, as well as AWS's continued support of this program. Absolutely amazing. Uh, so I would like to talk about here at Mission, one of the things we would like to offer up for attending today is a free migration readiness assessment. You might be considering migrating. You might be wondering where you should start. We'd like to offer a free consultative session. And a solutions architect like myself, sitting down with you, looking at your infrastructure, looking at what you do with it, and just kind of talking to you about your migration options, including using EMP and some programs that AWS, some other programs that AWS has available, and seeing if how we can best assist you and make it cost effective for you to move to AWS, and what applications you could take forward, or which ones might need to be looked at for EMP. So please, www.missioncloud/migrate. Go ahead, please sign up. Somebody will get back in touch with you as soon as humanly possible. And we would love to talk with you further about your unique case, because everyone has a unique work case because it's your workload. None of these are cookie cutter, but there are some tools to make it a little bit easier overall. And we'd like to help you leverage those going forward. So again, thank you for attending. From everybody at the Mission family, we'd like to thank you, and please be safe out there. Have a great day.